Welcome back. I'm Deborah Kaufman with Broadcast Beat at the 2017 SMPTE Conference and Exhibition. We're lucky enough today to have two people from Dolby here to talk about all the many things that Dolby is doing. Directly to my right, Craig Todd, who's the Chief Technology Officer at Dolby, and next to him is Jaclyn Pytlarz, who is Applied Vision Scientist with Dolby. So welcome.
Thank you very much. Nice to be here.
Good. So it's been, I hear it's been a very, very busy year for Dolby.
Very.
All right. Well, Craig, do you want to tell us some of the things that have been going on?
So last month at IBC convention,
Yes.
we were honored to receive the top technical award from IBC. They give out every year, so it was given to Dolby this year for 50 years of contribution to audio.
Yeah, amazing.
And I was honored to be able to pick up the award for Dolby. And in my remarks, I kind of referred to what Dolby has done in audio, starting with the analog noise reduction, Ray Dolbys, A-type, B-type, C-type, SR, that took us into the 90s. The developments in film sound, where we took a very poor monophonic track and turned it into high fidelity surround sound using the same optical track that's very economical to print on the film. And that, of course, started when television went stereo. Television could deliver those same tracks, which meant at home you could decode surround sound. And that led to the birth of the home theater receivers and surround sound in the home. And then, of course, we moved to digital sound in the cinema. On the same optical print, we were able to put 5.1 channels of audio, which drove us to develop Dolby Digital to be able to code it for that. And then, of course, Dolby Digital got adopted by the television systems,
right.
Laserdisc, DVD, ATSC broadcast, DVB broadcast, and that upped the game in home theater for sound. And that's sort of current state of the art. And then, of course, we have the new developments like Dolby Atmos in the cinema, which is a whole different way of producing sound. We just, instead of mixing it down in the cinema, you deliver all the elements to the cinema along with instructions as to where each element should be placed in space, and whether it should be a point object or diffuse, many parameters you can adjust. And the cinema industry just loves it. There's several thousand cinemas.
So do audience members, right?
Equipped. The audience loves it. There are thousands, I think approaching 2,000 titles have been mixed in Dolby Atmos. And of course, that's also going to the home. It was introduced into the home about 3 years ago, and it's now sort of reaching scale where the number of products, number of titles available, so it's starting to accelerate the growth and looks like it'll be a major success. And what's amazing is our engineers have even made it possible to get an Atmos experience, out of a sound bar.
Yes.
With speakers that are forward firing, side firing, up firing. And then with virtual techniques, even a device like a cell phone or a computer, where you know where the speakers are, using head-related transfer function technology, we can give the impression of an immersive experience out of that Atmos soundtrack.
It's pretty amazing, and I know anybody who hasn't seen or experienced a Dolby Atmos theatrical feature should absolutely go do that.
Yeah, and we
right
can
away.
deliver that with the current Dolby Digital Plus delivery system, which is widely deployed, so we don't have to impose a new codec to get this experience of the home. But of course, we do have a new codec, the
Right.
AC4 codec, that has been adopted by ATSC 3 and will be used in North America as a next generation television sound. And of course, we expect that to be widely adopted for delivery to mobile devices, home television, basically everywhere where sound goes. It's sort of the future system. It allows personalization of the audio from the different elements that are delivered. You can pick your language, pick whether you want audio description, which is a description of the visual elements for for visually impaired people, and of course we'll deliver Atmos and so forth as well. So we've got a lot going on in the audio space.
So that is a tremendous amount of achievement and accomplishment. Was the prize accordingly very, very heavy? The trophy or whatever it was?
It wasn't, well, it was a little cylinder, metal cylinder, which was dense, but not so large that it was super heavy.
So how many scientists, I mean, Jaclyn, you're one of the scientists, how many scientists do you have? This is a tremendous amount of activity, you know.
So we have scientists and engineers, and it's kind of blurry where the borderline is, because a lot of the engineers, you know, do fundamental work, and some of the scientists do applied work as well. But in terms of technical people, we must be like 500, you know, down and dirty into the technology.
Yeah.
At least 500, maybe 800?
Maybe.
It's hard to keep track of. We've grown so much in the last 10 years.
Apparently so. So one thing you didn't mention, but I know has been news for the year, has been news with Dolby Vision.
So in my remarks at IBC, the last thing I said was, I hope we get to come back someday and be awarded for our contributions in imaging, since we've been awarded just for sound. And of course, we started in imaging about 15 years ago. About 10 years ago, we identified that brightness and contrast were key attributes of the image, that improving those would have the most impact on the future. You know, not more resolution, but the brightness and contrast. So we started working in that area, and over the last 10 years, we've developed, you know, all the fundamentals of HDR. How bright should it go? How black should it go? How the signal should be represented. We brought that into the ITUR. We offered it as part of the UHD standard, BT.2020. It was too new for those people. It was rejected, but we kept plugging it away. And a few years later, ITU decided, you know, is this an enhancement for television? Is it new television? What is this HDR thing? And finally they decided this is really a new television system. So we created a whole new recommendation, ITUR BT.2100, that specifies the complete HDR technology, color, monitoring environment, transfer function, everything. And that is now becoming pervasive in the market. I mean, everywhere you go in television, the talk is about HDR.
Absolutely. I mean, that's been a big part of the conversation today. Is there any way to kind of, you know, give numbers in terms of adoption? You know, how do we judge what the penetration is?
So there's certainly
pervasive.
I mean, it's still early in the consumer rollout. So there's certainly millions of consumer displays out there. There's hundreds of titles accessible via Netflix, Amazon, Vudu. And the big news recently in September was iTunes, Apple and iTunes.
Yes.
So you now get HDR from iTunes, supported on Apple phones, the 8 and the 10, the current crop of iPads, and the current Apple TV will take in the iTunes signals and deliver them to your HDR Dolby Vision television display.
Well, obviously that's a big game changer potentially.
Yeah, we'll have, in another year or two, we'll have hundreds of millions of devices in the field just in the Apple ecosystem. So that's terrific.
That is amazing.
And the fact that Apple always does the best and that they chose Dolby Vision, we think is a great vote of confidence in our technology.
And I know that iTunes as well is also distributing some titles, is that correct?
So yeah, they've got over 100 Dolby Vision titles already up, and that's going to expand significantly, we think.
So the Apple acceptance is obviously.
So again, we're started reaching scale where the exponential growth is starting to take place.
Well, I remember at the time that Dolby Vision came out, people were scratching their heads a little bit like, wait a minute, Dolby's an audio company.
Yeah.
What's with the Vision stuff?
Like I say, we've been at Vision for like 15 years and working on HDR for 10 years. So
15
there's a
years
lot
ago,
behind this.
I'm hearing that. I didn't realize that 15 years ago, what was Dolby doing with regards to Vision?
We started by buying a small company of video experts. Company started by Gary Demos, who's very
yes.
well known. So it's called Demographics. And that gave us a core of expertise in the nuts and bolts of video processing and coding of video. And we used that team in the early days of digital cinema to help us contribute in that area, and then to contribute to our own digital cinema products. And they've become now a general research team, but we've expanded greatly, from that initial core of, about 10 people to more than 100 certainly working in the imaging area.
Well, it's interesting because I think everybody did see what Dolby Vision is being like, whoa, out of the blue, but as you're saying, it really wasn't out of the blue.
Yeah.
That it's really been planned for a long time.
I mean, initially we didn't realize Dolby Vision would be so much work, but we started in high dynamic range by purchasing a startup company that invented local dimming backlight technology, which was the key technology to allow an LCD to go brighter while still maintaining good blacks simultaneous on the screen, because you could dim the backlight in one area, keep it bright in another area, and have brights and darks simultaneous on the screen. And when that technology was used to display still pictures that were taken by a sequence of different exposures and merged to make a true high dynamic range imaging, the results were just stunning. But when we took, like motion pictures, or that startup took them and stretched them up to the full brightness, they just looked hideous. And it was like, please don't ever show those pictures to a movie person, they'll shoot you. They're so bad. And we realized that you had to produce the pictures for the media. And that kind of led into this swamp of, we had to develop the entire ecosystem, all the way back to production technologies, grading, how to deliver the signals, how to represent the signals, how to then handle the signals at home, because the signal box was so big that we created. Home displays aren't there yet.
Right.
I mean, home displays vastly exceed the legacy SDR picture container. So they go brighter, they have more color.
Right.
But they very much inside the new box we've created. So if you create and deliver a really big picture at home, it's got to be collapsed to fit on the home TV. And you like to collapse it as if the colorist had colored it for your television. But of course, there's such a variety in televisions. How do you do that?
Right.
And we hit on, this is what led to really the Dolby Vision key, which is the metadata that describes the picture and the intent of the creator. And you deliver the big picture and that metadata with the intent and characteristics of the picture on a scene-by-scene basis. And the television, which knows its own capabilities, then optimizes what was delivered for display on that particular set. So it can optimize everything from a cell phone, a tablet, a cheap TV with global dimming, a very good TV with local dimming, an OLED TV. Everyone gets the optimum experience. And you contrast that with current SDR TV, where you capture this big signal in a camera, which has much more capability. You crunch it down into this little SDR picture, ship that to the home, and then every TV expands it somehow, totally uncontrolled. And you get this vast variety of pictures at home that don't bear any relation, often, or little relation, to what the creative meant the picture to look like.
Right. I think we've all experienced that in the past. Thank goodness that's the past, right? So Dolby has always been a big supporter of SMPTE, is my understanding, correct?
Yep.
So, and you have a booth here.
So we usually have a booth. We usually show something leading edge. You know, we years ago brought HDR here to show people. We've shown our HDR monitors, which are the best in the world. We're working in other standards groups to get the signal home. We're working in broadcast groups, ATSC and DVB. And currently in ATSC, we have several technologies we contributed to become part of the standard, and they're now at a phase called candidate standard, where they're published, it's open, anybody can look at it, try it, play with it. And the key one for us is the metadata standard, to deliver this metadata over the transmission. So it's widely accepted now that dynamic metadata provides a great benefit when used at the consumer receiver. So in ATSC, we standardized that metadata in SMPTE 2094-10. What ATSC had to do was have a spec for putting the metadata through the broadcast signal. So we documented in ATSC what's called an SEI message. It's the way you put supplemental enhancement information into the HEVC codec. So that is the candidate standard in ATSC, and candidate standard means you should go out and try this and prove it. So what we're showing here is the implementation of that. It is the metadata, it was generated live into an encoder, it's being encapsulated per the ATSC specification, it's being played out into a prototype set-top box, and then conveyed over HDMI into a Dolby Vision display, where it's being used to map the picture to optimize it for the particular display we have. So it's proving the end-to-end link.
And you can see that actually at the booth.
Yep.
And I take it that, are you both available then to discuss some of the geekier details of it?
Certainly, we have lots of people here that are deep into the nitty-gritty.
Okay, and I see that one of them is sitting right next to you.
Yeah, so we're also demonstrating an advance in color reproduction.
Talk about that.
So
yes.
we have one of our color experts here who can explain that part of it.
All right, Jaclyn, talk about, you're part of the Applied Vision Science team, correct?
I am, yeah.
And tell me what you guys are working on.
So the demo we're showing here is a new signal representation called ICTCP. And this is a signal representation that was standardized over a year ago in ITUR and is now a candidate standard at ATSC. What it actually is, some of you may have heard of YCBCR before as a signal encoding format. Basically, it was back in the days of black and white television, they needed a way to add color, and so that Y was our black and white signal, and CBCR was adding color.
Okay.
And the neat thing about that was human vision is very good at seeing changes in luminance, but not very good at seeing changes in color. So they figured out, oh, we can actually get rid of some of the color information, reduce the amount of signal we have to send by using those channels. So they would cut CB and CR, that color resolution, in half or in quarter, and then send the signal. So we've used that for many years down the line, and now as we move to high dynamic range and wide color gamut, we're starting to see some issues where there's a lot of crosstalk between the color and that luminance I was talking about. And the problem is humans are really good, like I said, at seeing changes in luminance. So all of the camera noise and artifacts that happens now become really easy to see as we get to those bright colors, those saturated colors. So we see in the demo over there, you see a lot of noise artifacts, sparkly effects that happen. So what we've done is we've gone back to the drawing board and said, now that we have the resources, we don't need to support that black and white signal anymore. How can we optimize this system using the same system architecture, so it's compatible with existing systems, to be able to not have those artifacts? So separate that color information and the luminance so that the errors stay in color where we can't see it. So that's what the demo over there is showing, is this difference between YCBCR as we would use it for HDR wide color gamut and some of the issues that we can see with it, and then our proposed solution now using ICTCP as the signal encoding format.
And can you break it for people who are not engineers at home? Can you kind of explain a little bit what that actually means?
Essentially what it means is that using the same system architecture, you'll get a better image in your home. And that's the crux of it, is that as we move to high dynamic range, wide color gamut, we're getting better imagery to the home, but you don't want to distort it with legacy technology that we haven't updated.
And how long has Dolby been working on this for?
This has been a project since I started, actually. So 2 to 3 years we've been working on this.
And how close are you? I mean, it sounds like if you're showing something, you're already at a certain
So
point.
it's already in use in most of the delivery of Dolby Vision over the internet, the OTT services. I can mention Netflix is using it. So it's tried and true. This is how we deliver the best HDR. And it's obvious that the rest of the industry, broadcasters, should take advantage of it. It's hard to change their mind. We've been using YCBCR for 60 years, 70 years. I mean, that's how it's done, right?
Yeah.
What's this new thing? But the way they've done it, I mean, all you do is load some different coefficients into some multipliers in your equipment, and it turns it from YCBCR into ICTCP. It's a very gentle change over, and it provides these benefits. So if we're going from SDR to HDR and from gamma to PQ and from narrow gamut to wide gamut, like, why not change the color as well and fix the problems?
Well, and it's certainly a problem that people have seen and identified before.
Well, it's becoming more of a problem because of the wider gamut, and when you reach the more saturated colors is where it really stresses it. So some of these problems haven't really been seen to date, but they will be seen going forward, and we can fix the problem before we run into the problem.
So in other words, it's when people start implementing HDR and wide color gamuts that people all of a sudden say, whoa, what's that noise doing there? So I take it because that's really not happening in broadcast yet, people aren't really quite seeing it. Are you showing like a before and after at your booth?
What we did is we took a Grass Valley camera, and they've implemented ICTCP, so we shot some Legos, and we switched the mode between YCBCR and ICTCP, and we're just showing the uncompressed results of that shot.
Okay.
Yeah, I mean, the problem becomes apparent when you do processing on the YCBCR. So when you do the color subsampling to reduce color resolution in half, so all that's being done is the camera's taking it from 444 to 422, and then we're taking it back to 444. And just that little bit of processing is causing color noise to move in to become luminance noise, which is what it's showing. Now if you go to 420, it'll be even worse. And if you do other processing, it'll be even worse.
So in other words, it's just a matter of time before they adopt, they basically need, do you have competition on this score?
No,
Not really.
not in the color.
Yeah.
I mean, there was opposition at ITU, both from people who thought it was too new and people who thought they could come up with a better idea. It's
And you
like,
thought,
okay,
gee, I've heard this before, right?
you know, maybe in a few years they could come up with a better idea, but do you want to wait? I mean, this technique is really good.
Yeah.
And you know, maybe there's a better one out there by this much, but you don't want to wait years for just a tiny improvement, further improvement. So we're very gratified ITU did approve this, and now it's full speed ahead.
That's excellent. Well, obviously the OTT services have been able to adapt very quickly to HDR, and so they're the ones that are going to see it.
They don't need standards. They just do it.
They just do it, right. All right, well, I guess the rest of us will just catch up when we catch up, right?
Okay.
Great, well, so you're going to be operating at the booth. We can see this technology anytime today and tomorrow, I take it.
Yep, until they shut down the exhibits.
Excellent. Well, thank you both for joining us and telling us about what Dolby has been up to. Appreciate
Thank you.
it. And congrats on your award as well.
Thank you.
Take care.